So this is one of the most important assignments that you're going to see. And it could be a little bit confusing, but it all goes back to what we've been saying. F prime, if F prime is positive, then F is increasing. If F prime is negative, then F is decreasing. If F double prime is positive, then F prime is increasing, which means that F is concave up. And if F double prime is negative, then F prime is decreasing, which means that F is concave down. So there's the four things there. And you kind of tie these two to the first derivative. And then we use this. We use the first two, if you remember, to do our test for maximum and minimum. So right here would be a maximum, right here would be neither, and then this would be a minimum. So we use that test, that first derivative test for that. So that's really like a big portion of calculus right there, big portion of your AP test. So really important. So we got to figure out which graph is the original F, then which one's F prime, and then which one's F double prime. So F prime tells us where we're increasing or decreasing. So we got to figure out which one's the derivative of what. Usually the kind of the crazier one is our original function. So let's kind of start with 2 and see if this is the original function. So we're increasing all the way up to about this point. So if 1 was the derivative, it would be positive to about that spot, which it is, to about right here. It's positive. Then it's negative to about right there. So we're decreasing to about right there. This is looking pretty good. Then we change positive for that little section there. So we're increasing for that little section. And then negative for this section. So now we're decreasing again till we get to about right here. And now we're increasing again. So it looks like 1 is the derivative. So far I'm going to mark it. I'm going to say this is F. And this one looks like F prime. Now you'll realize this would be a maximum because it's going from positive to negative. We should see at this spot a maximum on the original graph because it's going from positive to negative. And if you remember like this test right here, when it goes from positive to negative, we have a maximum. So it is a maximum. And then it should be going from negative to positive right here because that's a minimum. And it does. It goes from negative to positive, that's a minimum. And then positive to negative, that's a maximum. And then right here, negative to positive again right there, if you look at those. If you're looking at the x-intercepts on the derivative graph. And you can see that's also a minimum. So it looks pretty good. At least, if this is F prime, this is F double prime. We know that this is the derivative of this one. So right here would be the concavity. Concave down until we get to this point right here. Yeah, it's sad till about right here. This would be the point of inflection. Let me put the points of inflection in. Let's do green. So that would be a point of inflection, which happens about right there. That's the right spot. And then it goes back to negative at this point. So right there, it turns to concave down again. Then from there to the right, we're positive again. So about right at 2, so right down here, we would see that it becomes concave up again. That happens right at 2. This one happens right at 0. This one happens kind of right in between the -1 and -2, so probably a little further up, like right here. So this would be F double prime. Once again, this might take a bit of time, but such an important assignment to get the hang of. All right, let's look at this one. And it's really, you just got to start at a spot. See if you can figure out the derivative graph. So maximum, I'm going to look at the critical points. That's probably the easiest way. So maximum here, minimum here. Let's see if we can figure this out. So we should see the first derivative go from positive to negative, right? Because increasing and decreasing. And that happens right here. And then from negative to positive, right in between the -2 and -3. So right there, right in between -2 and -3 goes from negative to positive. So it looks like this is F and this is F prime. Let's just double check. So we have a point of inflection right here. You can see it change from concave down to concave up. So look, negative to positive, this must be the second derivative because it's changing from concave down to concave up. So 1 is f, 3 is f prime, and 2 is f double prime. So it looks like A. Our last one here. So we're going to pick a graph once again. I'm going to go with, just got to start one place. I'm going to start, I've been right so far actually. Usually these might take a little bit of trial and error. So I'm going to go ahead and go with this one. Look at its minimum. And it has like a maximum about right here. So let's see if one of our graphs goes from negative to positive, because you can see this one's decreasing to increasing. So we would want to see the derivative graph go from negative to positive. And that's on this one right here, look, from negative to positive. And then between -2 and -3, between -2 and -3, it's going from positive to negative. So actually, look at that. This looks like f and f prime. You could actually tell concavity from f prime, really important. We'll go over that later. But because f prime is increasing, that means that f would be concave up there. And if f prime is decreasing, then that would mean that f is concave down. And we see that there. So it does make sense that that's f and f prime. And we're just going to check out that the other one, make sure it's the second derivative. Oh, is this might be this one might be the second derivative, this be the first derivative. That is possible. So this last one, just to check concavity, concave up to about right, it's about right here. And I'm not quite liking this. Because if you could see, it's positive to about right here. So I think finally I got one wrong here. So I know that this graph too is the derivative of this one. So why don't we make a quick little change? And I'm going to call this one f double prime, making this one f prime. And let's see if this ends up being the concavity, or if this ends up being the derivative graph to this one. So if I look at this graph, I have a maximum, it looks like somewhere over here off the graph. And you can see right here, it intersects the graph at about that spot, right? So it's going from positive to negative. That would put a maximum there. Then right here is a minimum. So I'm thinking of this graph as f right now. It is a minimum, so this graph should be going from negative, since it's f prime, should be going from negative to positive, and it does. So actually, this is the graph of f, this is f prime, and this is f double prime. All we knew is that this is the derivative of this one, so that's why we're able to make that change real quick. This would be concavity, so concave down to about right there. Yeah, concave down to about right there, then concave up to about right here, so yeah, concave up, and then around this area, it changes to concave down. So you know, that just shows you might have some errors in there. Trial and error, you know. It's going to take some time on this assignment, but take your time. Really think about how this right here relates to the graphs.